Hello. Welcome back to my font parsing and rendering project. Are we live? It looks like I'm live. Hopefully I have audio this time. Let me confirm that. Yep, it sounds like that's working. All right. So yesterday we drew a few outlines of letters for the first time. Today I would like to go from straight line segments to curved quadratic Bézier splines. So if I show you what I did last time, actually I didn't show this letter yet, but here's the letter B. This is essentially what we did last stream with different letters, but you have straight line segments in between every control point. And I'm now putting markers at every control point. I think I have to automate that because I think I did this manually in my Scilab plotting script. So fonts aren't supposed to be straight lines everywhere. At least this portion of the lowercase letter b, this is from the Arial font, by the way, these portions should be curved. The left side of the B here, that should be a straight line. So there's a mixture of straight lines and quadratic splines. And we should be able to decode that by looking at the flag that tells us whether each control point is on the curve or off the curve. Now, before we really get into that, I think I have some technical debt and things that I want to clean up from the last stream before we get into the meat of today. I think I have to make myself a list too. So first of all is the problem with read U16, I believe. At the end of yesterday's stream, we were having problems with the CI, where the thing that I was running locally on my computer wasn't yielding the same results in GitHub Actions. So that should be fixed. Let me go in and copy some of this output and double check. So first of all, I can get rid of this. Yeah, see, I went in and I added like these O markers so that you can see the control points. That is manual, so I need to automate that. Okay, so this is a clean slate, basically. We just have boilerplate at the top of this Scilab script. And then if I look at the results of this GitHub action, I should be able to copy and paste this straight into Scilab. Starting from around here, then if I jump to the end and copy all of that, this should be pastable into Scilab, and I can just run that. And that's the letter G. And now this is the same thing on the cloud that we were getting locally. I am putting one control point at the end. This is the final point, which I wasn't sure where it was. So I'm now displaying that with a marker. Now, the reason that I was getting different results locally and on the cloud is because of, was it read U8? Yeah, it was read U8, where I have this, I'm anding the thing that I'm reading with FF. But what I had earlier was without this stuff. It was something more like this. So the problem is that this is 1 byte. This looks like it's 1 byte. It's FF. But what FF represents is 255. Now that's the biggest 1 byte unsigned integer. The problem is that Fortran does not have unsigned integers, it only has signed integers. So when you have a 1 byte integer in Fortran, that possible range is like -128 to +127. Or maybe it's -127 to +128. I'm not really sure. But in either case, it's about half the range of an unsigned integer. So when we try to put 255 in here, that overflows, and then we and it, and we were getting the wrong result. but only on the cloud, not locally. So I think it's because there are different compiler versions that give different results in this statement. But if we explicitly cast to 2-byte integers, this is now safe from overflowing, because even a 2-byte signed integer in Fortran can still represent 255 without overflowing. So this is the safe and portable way to do that. And that is in read U8. But I think I have a potential for the same bug in read U16. U32 is safe. I'm already casting that up to 8, but I'm not doing it in read U16. So I think I need to fix that. The read I64s should be fine because these are trivial. Like, we already have unsigned integers in Fortran, so all we need to do is read it. We don't need to do any bit fiddling after reading or typecasting. So that's one thing that I want to fix. I want to reorder these into a logical order, or more of an alphabetical order. I want to refactor this so that this reads all of the glyphs, and then in a separate function will display the glyphs. So that shouldn't be too hard. And then I want to clean up that nasty hack. So read U16. I'm just going to do the x is delta, y is delta thing now. But then I want some longer term items on this roadmap as well. So hopefully we can get to this one today. Quadratic Bézier splines instead of straight line segments. Eventually I want to fill in the outlines. Well, before we even get to filling in the outlines, so instead of just plotting these outlines, I want to fill this in. But before we get to that, instead of doing this in Scilab, I want to do this all within Fortran. Scilab is good for like prototyping and visual debugging, but eventually I want to get this all into Fortran. Won't get around to that today. The C map, I want to handle the C map so that I don't have to hard code indices. Compound glyphs. If I only do ASCII, I don't really have to worry about compound glyphs, but I want to get to those things eventually. I also don't really know how far I want to take this project. I want to be able to do multiple letters. Like, I want to typeset a whole sentence. But then I don't know if I'll ever get around to breaking things up into lines. Like, I'm not trying to reinvent LaTeX from scratch. I'm not trying to make my own full-fledged typesetting software. This is just a side project, so I might not take it that far. I think that's most of what I want to do. eventually. Yeah, so first, before I even do any of that stuff, I want to refactor the way this X is byte stuff is handled. Let's get everything nice and aligned. Actually, don't want to use Y delta at all. I want to do everything with just the X values and then get the Y values. Notice 4 is twice as much as 2, and 32 is twice as much as 16. So that nasty hack that I put in the loop, I can do this in a more elegant way without just setting it before the loop and then setting it at the end of every loop iteration, because I really don't like the way that looks. So instead of doing that, I can comment that out, and then I can multiply this thing by the loop iterator. So if we multiply this by the loop iteration, the first time through the loop, 2 is 2. 2 times 1 is 2. But the second time through the loop, if we multiply this by 2, we get 4, and that's exactly the Y thing, the Y bit flag that we want to check. And delta will work exactly the same way. So instead of doing this here, we can put it inside the loop, and we can multiply it by j, because j is the loop iterator. So now the first time through the loop, this will just be x is byte. The second time, this will become y is byte. And then I don't need to do this at the end of the loop. So I think that looks a little bit cleaner. And this should still work. I want to verify that this works. This will go back to, I don't know what letter this is going to do, because I was testing some things with Arial font. Okay, so the letter B in Arial is at the same index as the letter B in Calibri. That kind of makes sense, but because, well, they're both Windows fonts. I don't want to say they're at the same ASCII value because it depends on the CMAP. But since Arial and Calibri are both Windows fonts, or no, this is computer modern. Okay, so that's more of a coincidence than anything else. So that's a letter B. Another thing that I can quickly show you that I did off stream yesterday is multiple letters in like a ad hoc way. So if I go to where this is called, let's go 69 through 79. I actually haven't done this range exactly yet. So we can run that. Copy, paste into Scilab. Eventually when I get this all into Fortran, I won't have to go through this copy paste step. But there we can do multiple letters. The kerning looks terrible, even if I fix the aspect ratio. So like the B and C are squeezed together, like they're literally right on top of each other. But then there's like a reasonable amount of space between the C and the D. So there is no kerning really. The way that I did this is I'm just adding 1,000 to each glyph. So where I'm where I'm writing Scilab code, I add 1,000 to the x coordinate multiplied by the glyph index. So basically these are 1,000 f units between each character. So 1,000 is a good spacing from C to D, but it's not a good spacing from B to C. So some letters look better kerned than others with this method. It's not a good way to do things, but it does allow me to like look at multiple letters and see that I'm parsing things correctly at least. So go back to just one letter. What was it 74 for G? I think I like the letter G. The letter G is very interesting in most fonts because it has multiple. It has more than just one or two contours. It has 3 contours. So that's back to the letter G again. I don't know if I need to bother committing that because there are a couple other quick things that I want to clean up from yesterday. I also fixed this bug where I was reading the number of contours as an unsigned 16. That should be signed because there's this scenario where if it's a negative number, that means it's a compound glyph. So earlier I wasn't detecting compound glyphs correctly because unsigned integers can never be negative. So it was supposed to be read like this. It happened to work for most cases because usually the number of contours is a small number where the bit representation of an unsigned integer is exactly the same as a signed integer. But for compound glyphs, that wasn't right. And I want to fix read U16 as well. So the way that we're casting things here, I want to cast here as well. The problem is I16 is 2 bytes, but this could overflow 2 bytes. So I need to cast up to a 4-byte integer. So I make that a 4-byte integer, and then make this a 4-byte integer. If you notice, every time I compile, I get a bunch of warnings. I think this was one of the warnings. Yeah, like there are these warnings about different type kinds. So I think that was one of them, but now that particular line shouldn't warn anymore. So I should really pay more attention to these warnings and fix more of them. Like some of them really don't matter, so I kind of want to ignore some of these warnings. But that should still be correct, hopefully, so let's verify that. It's still G. And I want to reorder these because I have these in a random order. Like I have read string and read fixed, those are okay. But then I have 64, then 16, then F word, then 32. So I want to get these sorted in some kind of like alphabetical or numeric order. So I'm going to put fixed. I'm going to put F word right below fixed. And then I want to have all of the integer type parsers next to each other. And I probably want to have those in ascending order. So 16 and 8 are going to be near the top. Eight, then 16, and let's put signed before unsigned for the cases that we have those at least. Like I don't have a read I8, I only have read U8, but then I want to have read I16. I want read I16 before read U16. So that's alphabetical. not actually changing anything, I'm just rearranging the order of functions. I think that's it. No, let's go totally alphabetical. Let's have. No, I don't want to have string in the middle of my integer readers or numeric readers. So I like having string at the top. Maybe. Yeah, I'll just leave it like that. So string, fixed, F word, U8, I16, U16, U32, I64. There are a couple that are missing because I just haven't happened to need to read those types yet. I'm not sure if TTF even uses like an unsigned 64-bit type or a signed 32-bit type. So there are a few that are missing, but I think the ones that I have are in a good order now. Let's verify that. Still G. All right. I think I'm ready to commit. Biggest thing was fixing that U16 potential overflow issue. I haven't actually seen any issues come up because of that, but I've had a bug for like the 32-bit reader and a bug for the 8-bit reader, so it makes sense that the 16-bit reader could also have that same problem, unless I cast things in a consistent way. There are a couple other things in that commit. So that commit message isn't totally descriptive. But let's verify that that still works on Ubuntu on the cloud. It's done already. Still G. All right. Now there was one other thing. Before we get to the splines, I want to refactor the glyph drawing outside of the glyph reading function. So after I get that tech debt out of the way, then I can move on to today's actual feature, which is doing quadratic Bézier splines instead of straight line segments. So I want to take this and move it somewhere else. Because I want to load and read and parse all of the glyphs and then draw some of them. Let me delete this return. So that's one I want to take out into a separate function. I guess we can call it draw glyph, even though it doesn't actually draw anything in Fortran. It just prints Scilab code, and then the Scilab code draws the actual glyph. I'm not sure what arguments this is going to take yet. So there's a to-do note here. I also have that covered at the bottom. So in loading, it's not really a big deal. Okay, maybe it is a big deal. I might want to make this not a fatal error. And then I can load everything, but then if you try to draw a compound glyph, I can make that an error. So I might change this. I'm going to try leaving it as is for now. But we have this draw glyph function. We need to declare some things. It's going to take the glyph as an argument. What else does it need? We have J, we have the glyph. That might be it. I'm not even calling this yet, but I want to see if it compiles. It doesn't. It's not surprising. I never get anything right on the first try. I do sometimes, but it's pretty rare. Right, the result. Oh, an I glyph. Maybe I just don't want to use I glyph for now. I'll leave it there. But the point of this is for kerning. So I was drawing multiple glyphs, and I was using this to space out the x coordinates so that it's... I don't know if you remember when I had like B through H, or whichever characters I was displaying. They weren't on top of each other. They were spaced out by 1,000 F units. These are called F units. It's whatever the coordinate that the font is defined in. Those are called F units or font units. Those are different from Ms, which we have this ppm, the lowest recommended points per M. That's another set of units. And then you could also have physical units like inches, even though inches don't really make sense on a digital display because you have like the resolution of the display, but I don't necessarily know how many inches wide my monitor is, and I don't really care about it either because I think when most people look at stuff digitally, they're not going to do it at the default 100% zoom. They're going to like change the zoom size. So it's kind of arbitrary, but there are different units that we should be somewhat aware of. So this might compile now. No, the return value. So what do I want to return from here? I think I'll just make it a subroutine and return nothing. That compiles, and you can see there's no more Scilab code here because I'm not calling drawglyph. Then instead of just reading one character at 74, I should be able to read everything, except if there are compound glyphs in here, this might be an error. Okay. So it seems that there are no compound glyphs in the LaTeX Computer Modern font, which is a little bit surprising because I think they could use them. But that's the number of points. Yeah, but the number of contours is always positive. So when you have a compound glyph, that's flagged by having a negative value for the number of contours. If I look at Calibri instead, I think this does have compound glyphs. Yeah, so it reads like 5 or 6 glyphs, but then it says error, compound glyph is not supported. You can show that if font drop will cooperate. And for some reason, I think I need to restart Chrome. I don't know why Chrome is being like this. Yeah, we'll come back to that in a minute and see if Chrome is cooperating. So I guess I'll leave this where it is for now, and I'll mainly work with the Computer Modern font, which doesn't have any compound glyphs. So I might change that, but for Computer Modern, I don't really need to. I think I can take out some of this printing. That's a little bit cleaner. Then I want to call draw glyph somewhere. I'm going to do that from main for now. For now, at least. Where do I want to hard code which index? I guess I'll have that in main as well. Draw glyph, and then it just takes the glyph, which is inside the TTF struct. And we'll just hard code 74 in here. Actually, let's do 75 should be H, I think, as long as those are sequential so that H is after G. So let's see if this makes an H. Printed something. Let's save that to a log file so that I can copy and paste easier. And let's plot it. Come on. Come on. There we go. That's an H. I think that's it for that refactor. I think I can just take out that line of code because I'm doing that in main now. Like I want to load all the glyphs, and then if I only want to draw one, I'm doing that from main right now. So does that still run? Okay, I think I'm ready to commit that. It's not actually a function, it's a subroutine for now. But I use the term function loosely because every single other programming language doesn't really distinguish between functions and subroutines. Only Fortran does that, where a function returns something and a subroutine takes arguments, and it might have output arguments, but it doesn't return just one value the way that a function does. I don't know why this website isn't working anymore. It just randomly stopped at some point yesterday. And it works in Firefox, but it's not working in Chrome anymore for me. So I guess I'll just bring over a Firefox window. But first I want to verify that this still works on the cloud. Maybe I'll check Mac as well to be a little bit more thorough. Since I don't have any testing yet, the only thing the CI does is check that it compiles and runs without crashing. It doesn't actually compare the results to anything. So that's a G. Let's take a look at what Mac is doing. Windows doesn't actually run it because I think there's a bug in GitHub workflows. Yeah, that all looks good. So I wanted to show something on font drop, but since Chrome isn't cooperating, we can do this in Firefox. Maybe I'll just totally switch over to Firefox for this video. Okay, there's Firefox. Let me get everything open in this browser now. Is it really still running? What is it still? Windows. Windows is slow for no particular reason. Okay, so this is what this website is supposed to look like. Yeah, I can't remember what I was going to show here. I think it was compound glyphs. Is this one compound? This is Arial. So like I think Calibri was compound, right? Which one? Huh. I don't actually know which one it was reading at this point. So I think I want to print the glyph index. Just realized I don't have my always on top window here to make sure that I'm not hiding things behind my webcam. There we go. Now, I can't see what you can't see. But this line is too long. I want to be able to see my get status. Maybe I want to put my webcam in the top right. I don't know. I'll just move it up a little bit. So, to do that in OBS as well. There we go. Now we can see which column I'm at. So this, I like to keep a text width of 80 characters. So at this point, yeah, I want to break up this line. Might as well break it up here. And then that's within 80 characters, so we're all good. Does that look okay on the stream? Yeah. I wasn't sure if I was able to like move my webcam midstream, so apparently that works. Now I know. so I want to print the index. I have to recompile. Yeah, so it's glyph index 5. It's printing right there. Got to stop using Chrome. I might just close Chrome since it's not cooperating. And now the problem is I have 2 Firefox windows, and I don't want to show the window that I have open all the time with like a million tabs in it. So index 5, we have 0, 1, 2, 3, 4, 5. Is this 5? It's index 5. Yeah, so this is apparently a compound glyph where like this is one simple glyph, and then this isn't a duplicate contour. This is just a reference to the first contour, but transformed so that it's translated over. So that's what a compound glyph is, and I don't know how to read those yet. I'm probably not going to do that today. What I want to get to today is splines. So what have I done? I've done nothing, but I think we're ready to get to the splines. Yeah. So we're going to handle that in the drawGlyph function. Do I have flags in my glyph? Okay. And we haven't really unpacked anything. I don't know if I want to unpack flags, because it will be a little bit more memory efficient if I leave everything in this byte array. Actually, it's 2 bytes. This is the signed versus unsigned problem again. In C, you could do this with 1 byte. In Fortran, I think you have to do it as 2 bytes to be safe. It might be possible to be very clever and encode it as 1 byte and like add and subtract on the fly so that you don't overflow. But the way I'm doing it is using 2 bytes to represent an unsigned integer in a signed integer. But they're not unpacked. If I unpacked these into the individual bits, that would take up more memory because you can't really have a bit vector in Fortran. You can just have an array of booleans which are 1 byte each at minimum, or more if you use the default boolean. So I think I want to leave these flags packed and then unpack them on the fly in drawGlyph. Like this. So like this checks the delta flag. We're going to have to do the same thing for on curve or off curve. You notice I have 32, 16, 8, 4, and 2. The missing one is 1. So bit 1 is the on curve flag. So I'm going to copy and paste the bit tester, and that's basically like that. Instead of repeat, we have this parameter on curve, and that's 1. Right, repeat is 2. No, repeat is 8, x is byte is 2. So on curve is 1. So now I have to reopen everything in Firefox since Chrome isn't cooperating. Yeah, so you can verify that here. If you search for on curve, that's 1. And then this blog doesn't actually use it. So he gets the flag, but then he never uses this anywhere. So if you search for on curve, it's just in these 2 places, and he doesn't actually use it. But I want to go ahead and then check this flag to see if points are on curve, and then whether they're splines or not. So right now I think it's time to do a little math. I do usually like to do math on paper, but I don't really have a good way to point my webcam at a piece of paper. The camera can angle a little bit, but it can't like angle down far enough for me to display a piece of paper well. So I think I'm going to do math in a text editor, like Zoding. Not because I like that, but because that's the only good way I can do it on stream. So where do I want to do that? Let's do it over here. Let's make a doc folder. Let's call it bezier.txt. So there are different types of control points. Let me go back to the letter B, because B has straight lines. I think 69 was B. I hope this is B. That's B. Oh yeah, this is computer modern. So I might want to switch to Arial or something, because I know Arial has straight lines. Even this B, it has curves, like at the serif here. But there's probably a straight line somewhere. So the idea is that like some of these points are on curve, and when they're on curves, it's a straight line. When you have two adjacent on curve points, that's a straight line. But when you have off curve points, that defines a spline. Now for a line segment, you can linearly interpolate between the start point and the end point. And the nomenclature that everybody uses for linear interpolation is lerp. So lerp is linear interpolation. And if we have a function, you can define a function for lerping. So lerp of A, B, and T. So lerping is, let's say you have a start point here, and you have an endpoint here. So the start is x equals, you probably can't read this, and there's, yeah, I can zoom in on the graph in Scilab, but I can't change the font size easily. So the coordinates are unreadable, so I'm not even going to say them, but this is the start point and this is the end point. Let's call this A at the start, and let's call this B at the end. So to lerp in between A and B, we want to have some parameter that moves us along the line. So here would be t equals 0, and at the end is t equals 1. And then t equals a half would be a midpoint, or t equals a quarter would be a quarter of the way along the length of this line segment. So the way that you do that, lerp of A and B at arc length t is A plus t times b minus a. So at t equals 0, it's just a. And then at t equals 1, the a's cancel out, and you end up with just b. Now the equivalent way to write this, if we group the a terms together, it's 1 minus t times a plus t times b. So that's a line segment. And then a quadratic Bézier spline is like a lerp of a lerp. For a quadratic spline, we have 3 control points. So instead of A and B, we're going to have a third one called C. So A and C will be on the curve, and then B will be off the curve somewhere in the middle. I should really draw this. I'll pull up a figure after I go through this derivation, but I don't want to pull up the website which shows the final equation before I derive it. So bear with me for a minute. So that's a linear interpolation. And then a quadratic Bézier spline is a lerp of a lerp. Let's not capitalize that. So what do I want to call that? Call it Bézier 2 for quadratic. If you had a cubic Bézier curve, that would be like yet another lerp. But for quadratic, that's like second order. Cubic would be like third order. So for this, we're going to have A, B, C, and still T. Now that is, it's like this formula, but instead of lerping A and B, we're going to have other lerps in here instead of A and B directly. So it's going to be 1 minus T. Oh, it's really a lerp of a lerp. So we're going to have something in there, not sure yet, and T. The first thing is actually another lerp. And the second thing is another lerp. So this is A and B, again with T. And this one is B and C instead of A and B. And the arc length parameter is always T. If you haven't seen this video yet, Freya Holmer has an excellent video about splines. I will put that in the description. It's like, yeah, I will put a link to this in the description. Why does that take so long to start up? What are you doing, Yovan? It's about to give up there. I might be misspelling her name. I'll go back and fix it later. Sorry if that's wrong. So she talks about this as well. I think she gets into cubic splines more, but a quadratic Bézier spline is the same idea. So it's a lerp of a lerp. And then if we expand this, like if we substitute this into the formula from this line, if we substitute that, we get 1 minus T times lerp AB plus T times lerp BC. And then if we expand that again, hold on, there's a typo in here. If we expand that again, this is 1 minus T times A plus T times B. And then this one is similar. I did not yank what I wanted to yank. Trying to be fancy with Vim, and it's not working. So now if I paste that, there we go. But now instead of A and B, this one is B and C. Then we can expand that more. So that's 1 minus T squared times A plus 1 minus T times B. So that expanded all of this term with this. Now we have to expand this term. Again, we have another 1 minus T times B. So we'll group that together in the next line. And then finally T squared times C. So we can do one more simplification. A term is good. Here we have 2 times that. So that's it. If I haven't made any mistakes, I think this is the final form for a Bézier spline. You know what? Coding has some good points. When you do math in a text editor, it's a lot easier to copy and paste because there's no way to copy and paste with pen and paper. So this is our final formula for a quadratic Bézier spline between points A, B, and C. Again, A is the start point, that's on the curve. C is the end point, that's also on the curve. B is the off-curve control point. It's somewhere in the middle. It's not actually on the curve, but it controls how the spline is shaped in between A and C. Okay, now I can pull up this figure without having spoiled the formula. What did I search to get there? Is it this one? Yeah, this is the link. So here's that formula that we just did. He has a little bit extra subscripts, so I think you can verify that those are the same. We have 1 minus t squared times a, 2t 1 minus t times b, and then t squared times c. So that's the same formula. This is like expanding it as scalars when you really want to have a vector. So if we have a point with x and y coordinates, you could do this formula twice like this. Or if your language supports vectors or arrays, a, b, and c could be vectors. So instead of having to do this twice for x and y, you can just do it all in one function. I think that's the way that I'll do it. I'm not quite there yet. We'll have to program this and see how it turns out, but that's the idea. Now the other thing that I like about this website is that it shows us on-curve versus off-curve points. So like from point 1 to point 2, these are both on-curve points. So that's just a line segment. That's not a spline. And then again, from 2 to 3, it's a line. 3 to 4, that's a line. But then from 4 to 5 to 6, this is a quadratic Bézier spline. So 4 is the on-curve point at the start, 6 is the on-curve point at the end, and then 5 is the off-curve point in the middle. And that's displayed as an X. So they're using square markers for on-curve points and X markers for off-curve points. I think I want to do that first in Scilab before I get to actual splines. Hello, Connie Lowell. Welcome to the stream. Thank you for tuning in. I really appreciate it. Let's see if I can draw markers like this in Scilab. So I'll do that inside the draw glyph function. And that's why I want to know whether points are on curve or off curve, so that I can know which kind of marker to use. I think I can do a separate loop that just goes through all the points. I really don't care about this final point anymore. But we can use that as a template. Let's do, let's do I, from 1 through the number of points. First of all, can I plot things with markers? That's the first question. Why do I use Fortran for work, or just because I like the language? Both. I use it for work, but I also unabashedly like Fortran. It's not perfect. Every language has flaws. Like I wish Fortran was better with pointers and low-level access to memory addresses. I wish I could declare types in line instead of having to declare everything at the top of the function or subroutine. So it definitely has flaws, but it's really good as an array-oriented language. Like this X member of the glyph struct, this is an array. Too many X's. Come on, where is it? Yeah, so this is an array. It's a rank 2 array, or other languages might call this a matrix or like a 2D array. Basically, like there's one index for whether it's an X or a Y coordinate, and then there's a second index telling you which point in the array we're looking at. So Fortran is really good with stuff like that. Like the way that you would do this in C is you would have like X, 0, and then you have a second set of square brackets for like the point index. That's like a really ugly syntax for me, where we have these back-to-back brackets. In Fortran, it's just X, 0, comma, I. So I think Fortran has a cleaner syntax for arrays, and it's easier to allocate them too. Like in C, this would be an array of arrays, and you have to like allocate the outer array, and then you have to loop through and allocate all of the inner arrays if you want to do it like this. Or you could pack it into a rank 1 array and then do the math to convert the 2D index to a 1D index. But that's annoying too, and then it gets really hard if you go above 2D and have like a 3D array. So that's one of the things that I like about Fortran. And yeah, so there's one of those array references. Yeah, you're used to it. It's kind of like MATLAB, if you've ever heard of MATLAB. MATLAB was inspired by Fortran, so it has the same sort of array notation. And then there are other languages too that I haven't used, like Mathematica or Julia. I think they also have some of these same array features. Okay, so I want to go through these points and plot them with markers. So this is I, and that is I. Let's just do an O marker for now, and let's see what happens. That didn't compile. Sorry, I have to move my webcam a little bit so I can see my chat window a little bit more clearly. Okay, I have like a missing end-if or something. Heard of MATLAB, but not a big fan of proprietary systems. Yeah, me too. For this project, I'm also using Scilab. It's kind of not that great, but it's like a free version of MATLAB. So I'm using this for quick visualization. Like I can just plot the letter B. Eventually, I want to get this all into Fortran so that I can do my parsing and visualization all within Fortran without having to shell out to a separate program. But for the first prototype, I'm using Scilab to quickly plot things. So it's kind of nice. It's nice that it's free. I never use MATLAB anymore because I'm no longer a student, so I can't get the free academic license. You don't really have a use case for something like MATLAB? Yeah, not everybody does. They're good for like numerical computing, and if that's not what you're doing, then there's no reason to use MATLAB or Scilab or even Fortran. So, what did I mess up? I think I have to read my error message. But we're getting cascading errors here, so we have to scroll all the way up to the first one. Oh, you're a low-level dev? Yeah, you use C or C++. Really low level. How low? What exactly do you work on? Oh, I accidentally deleted something way up. I don't know how I did that. So this, I don't know how I deleted that. Okay, so I think this is what I wanted. Let's redirect that. Let's see what this looks like. So this should put markers everywhere. Yeah, and there we go. Now we have, in addition to the line segments going between control points, we also have these dots or these circle markers at every control point. Now some of these are on curve, like this is an on curve point, but others are off curve. So I want to be able to distinguish those and use a different marker for them. Bare metal programming of microcontrollers and stuff like this. Okay, that's cool. I haven't done anything like that. Controllers like, do you work with PID control? That type of control? So I want to check the on curve bit. So instead of repeat, we want to look at on curve. And if that's non-zero, that means it's on the curve. And if it's off the curve, let's use an X. What did this other website do? Yeah, this website uses X's for off curves. So let's do the same thing. See if that works. This might not even compile. Nope. Flag. Okay. So this is inside the struct. It's inside the glyph struct. I think we can just access it like that. Hopefully I saved it. More like Arduino, but instead of Arduinos, I use ESP32, if you know it. No, I don't know ESP32. Sorry. Flag is not a member of the glyph struct. Why not? Oh, it's flags. Yeah. So I think I want to have a local variable and say flag equals glyph flags I. And then what type is this? It's integer 2. I've heard of Arduinos. I never worked with Arduino myself. I think that ran. Yeah, now we have a mixture of X's and O's. Let's see what that looks like. I think that looks correct. Let's compare that. No, I did not want to open Chrome. Chrome is not cooperating for me today. Yeah, so I'm using circles instead of squares. What's going on at the end there? So we have, oh, this is not even the same font. Let me switch to Arial. Oh no, we have a compound glyph. Microcontroller with integrated Wi-Fi and Bluetooth, 2 Tensilica Extensa LX6 cores. I can't even read these words. I don't know what that's beyond me. And a bunch of GPIO and different kinds of common interfaces. Sounds cool. Is that what you do for work, or is that like a side project? Okay, so I have compound glyphs that I don't know how to read yet. I think I want to just ignore them while parsing, and then not make it an error unless I try to draw it. So this is 98. I should be able to draw other glyphs as long as I don't try to draw a compound glyph like 98. So like I was talking about before, I think I want to move this and not make it an error. So on reading, we'll just return early. And then on drawing, if you try to draw a compound glyph, that's actually an error. I'm currently a uni student, but before that I worked at a company where we were doing heavy vehicle, trucks, buses, etc. automation. Okay, yeah, that sounds cool. So you're like working on that for a class? Okay, I wanna see if that error gets handled. So I think it was 98 was the first compound glyph. So it should print this for the simple glyph, and then it should error out when it gets to a compound glyph. Yeah, that looks good. So now we have an error message. Nope. ATM, just my own projects. Okay, yeah, that's cool. Yeah, I think it's more fun when you work on stuff as a side project if there's not like this impending pressure of like having to work on something for a class or having to work on something for work. When you do side projects, you have more freedom and you can go at your own pace and there's no pressure. So I think that makes side projects fun. Oh, smart home stuff. Yeah, that's cool. So you're getting a tangible benefit out of it too if you're improving your living situation. I don't get anything out of this. I'm just drawing some font glyphs on a screen, so that doesn't help me at all. But I still have fun with it. So yeah, and if you do side projects, you have stuff to abandon. Yeah, if I get tired of this, I can just stop. If it doesn't work, that's fine. Nobody else is using it. It doesn't matter if it's buggy and terrible. So this should run without errors now, and I want to redirect that. And when we plot this should be exactly the same as that website. There we go, that's the aerial B. I can't even count how many projects I've abandoned just because of boredom. Yeah, same. Well, actually I can count because most of them are on GitHub. So if you look at all the repositories I have on GitHub, that's a pretty comprehensive list of everything I've abandoned. I have a few things that aren't on GitHub, so it's not 100% comprehensive. Okay, so now this looks pretty good. We have on curve points here, 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 and here, and then we have the first off curve point here. And if we compare these side by side, it looks like they're exactly the same. I'm too lazy to push my stuff to GitHub. Yeah, I don't know, I have mixed feelings about that. Sometimes if I'm working on a side project, like maybe I don't want to have it on GitHub if it's not like ready or polished or something like that. But I actually feel safer when I have version control. If I don't have version control, then I feel paranoid that like I'll break something and not be able to undo it. But if I have it pushed on GitHub, first of all, I have version control. Second of all, you still use Git, but you just don't push it. Yeah. Well, so the other thing besides version control is backup. Like when I push it to GitHub, there's a backup there. So like if my computer burns down or something and I lose a hard drive, like it's still on GitHub backed up. So I think these are the same. Let me actually plot it with squares instead of circles for the on curve points. How did I do the marker? Wrong program. Yeah, so instead of a circle, I want a square. I think that's S in Scilab. Yeah, now we have S's. And this should be like exactly the same as the website now. Yeah, that looks good. Now that we know which points are on curve and which points are off curve, we can get rid of these bad line segments which aren't supposed to be there, and we can actually draw a spline around the off curve points. So we're going to have to iterate over this glyph. This is nice because it shows you the numbering too, so this is 0.1, or no, this is 0.0, that's the first point. Here's 0.1, 0.2, 0.3. So when you have two on curve points in sequence, like you have a square at 0 and a square at 1, you connect those with a line segment. So we can iterate through points, and if the current point and the next points are both on curve, then we do a line segment. So that will get us up to 0.4. And then at 0.4, we're going to do nothing because we already handled the line segment from 3 to 4. But then from 4 to 5, this is not a square, so we're not going to do a line segment there. When we get to 0.5, this is off curve. So we're going to check and see that the previous one, we're going to have 3 points basically around 5. So around 5, we have points 4, 5, and 6. So those 3 points define a quadratic Bézier spline, and we can draw that. Then something similar happens at 7. Well, something different happens at 7 because we have no on-curve point. Actually, TTF fonts are compressed so that when you have two off-curve points in sequence, 7 and 8, what you're supposed to do is make a new on-curve point exactly at the midpoint. So between 7 and 8, we have like a phantom on-curve point, and then that's how we define a spline around 7. How much time have I spent configuring NVim? A lot of time, maybe like 2 or 3 weekends. Before NVim, I used Vim, like classic Vim script Vim. So I was using that for like almost a decade, and then within the last 2 months or so, I switched to NVim. So yeah, it did take a while to configure. I just realized you're using NeoVim on Windows. You're only the second person I've seen to do so. Yeah, that's right. I'm using NeoVim within tmux, within WSL. So at the same time that I switched from Vim to NeoVim, I also started using tmux, and that's like my window manager or my tab manager for terminals. So I can switch from this tab with my editor to this tab with a shell where I run everything. So I spent a lot of time configuring tmux too. That might have been worse than nvim actually. But it's good because now I spend a lot less time using the mouse. Just the last 2 days I've nuked my nvim conf 3 times. Yeah, it's good to have a clean start sometimes. Yesterday you decided to start using tmux. Yeah. My problem with my previous workflow is that I was using Vim, but I was using gvim with every file open in a separate window. So I would waste a lot of time using the mouse to switch between Vim windows and then switch from Vim windows to terminal windows and back and forth. But now that I'm using tmux, I spend less time using the mouse. Sometimes I like the scroll wheel for navigation, or for like just highlighting things, I'll use the mouse. Also, I can't quite figure out copy and paste yet. So when I copy and paste from Vim to some other window, I think the best way to do it is right click. There is this unnamed buffer where you can set up Vim to use the system clipboard, and then you can use yank input to get into the system clipboard. But my problem on Windows is that it's really slow for some reason that I can't figure out. So what have I done? I might want to commit this. Yeah, copy and paste is a nightmare on Linux. Well, on Linux, instead of Control-C and Control-V, you have Control-Insert and Shift-Insert. But like even that's not portable, like depending on what terminal you're using, or if you're SSHing into a Linux box, then like that might not be portable. Yeah, it's a nightmare. So I think I might want to commit now before I start the actual spline work. So that runs okay. In my case, copying in terminal is Control-Shift-CV, so same as Windows, but in nvim it just doesn't work. Yeah, that's my problem. I can show you my nvim config. Where do I want to do that? Yeah, might as well do it here. So there's this thing you can do where you set the clipboard, and it took me forever to figure out how to do this in Lua script instead of Vim script, because a lot of the examples online showed this with the old-fashioned Vim script. So that took a while to figure out. Or rather, pasting from outside into nvim works fine, but using copied in nvim doesn't work outside. Yeah. So what I'm doing is like I just right click. I right click and then copy, and then that works. Like I can paste into my browser. And there you see what I just got out of nvim. That's in my browser now. But it's really annoying to right click. So if you want to use the yank and put shortcuts instead, this should work, but the problem is it's really slow. Is this the one that works? I was experimenting with a few things, so I have a lot of stuff commented out. But yeah, if I write this and then quit and then restart Vim, that's just the easiest way to resource the config. Now, if I just select this and hit yank, this doesn't feel right. This was too fast. Anyway, let's see what happens. Yeah, so I yanked that. Let's see if I can paste that. Huh. Why did that work and why was it fast? Yeah, so let me explain what happened there. So if I delete one letter at a time with the X key, that pastes into my system clipboard now. So if I hold down X, it should delete a bunch of characters really fast, but you're going to see that there's a lot of lag. So I'm going to hold X right now. And look how slow that is. That's terrible. And I let go of X, and it's still deleting because it's slow as fuck. That's because like it's shelling out to clip.exe to put things into the system clipboard. So if I undo all of that stuff and then I comment this out again, yeah, I don't know if it's a Vim problem or a WSL problem or a tmux problem or what, but if I comment this out and then restart, now I should be able to hold down X, and that deletes at a pretty reasonable pace. So for now, I'm just not using it, and then if I want to copy and paste to a separate window, I just right-click and copy and paste. So yeah, I think it probably is a WSL problem. It's not entirely Vim's fault because it has to use this clip.exe. I think I didn't change anything. Let me make sure I didn't actually change something there. Okay, yeah, we're good. Okay, so I wanted to commit. All right, next I want to actually get to the splines and plot that. So instead of this, well, I can delete that. So instead of this, where I might line segments in between everything, I want to do something different. So I still want the same structure of the loops. Okay, so we still have an outer loop through the contours, and then an inner loop through the points within the contour. So to review what that means, the letter B has two contours. It has the outer contour, and then the second contour is this inner contour, which is the hole in the middle of the B. So that's what contours are. So within each contour, we have a series of points. So that's why we have two do loops here. Now, if we have a square followed by a square, so if the current point is a square, meaning it's on the curve, and the next point is also a square, we're going to do a line segment. But this is tricky because when we get to the last point in the contour, the next point is not really the next point, it's back to the first point of the contour. So we have to have this wrapping around thing at the end of the contour. What about a capital B? A capital B would have 3 contours, so I should be able to show that. I'm using this website called Font Drop to verify the things that I'm looking at. So I need to know what index this is to plot. So this is 37. Let's take a look at 37. So if I draw the character at index 37 instead, what happened there? Oh, because I commented everything out. So of course that did nothing. Okay, this should print something now. So if we plot the capital B, I should have 3 contours. So again, there's the outer contour, and then there's one contour for the top hole and another contour, a third contour for the bottom hole. So that's a capital B. Yeah, I guess this is also a good case. I just want to make sure whatever example I'm looking at has straight lines. This has straight lines. And then I also want to make sure I handle the case where I have consecutive off-curve points, and this has that as well. Doesn't it have 3 contours? Yeah. I was just wondering how the code would handle 3 contours with 2 loops. Okay, yeah, so they're nested loops. I explained this a little bit on my stream yesterday, but you haven't seen that, so I'll do this again. There's this thing called endpoints. And then I think you also want to see the number of contours and the total number of points. So let me print those. So there's a lot of stuff in there. Oh, this is the reader. So that's not really clear. So let me print it here instead. So you want to see the end points and the number of points and the number of contours. Okay, so that's a little bit more manageable. So in the letter B glyph, we have 43 points. I'm not going to bother counting all of them, but yeah, I'd say it looks like there's roughly 43 points here. And then there are 3 contours, and now the end points are 17, 29, and 42. So that means that my first contour starts at point 0 and it goes up to point 17. And then the second contour goes from point 17 to 29. And then the final contour goes from point 29 to 42. So the way that this nested double loop is working is it's looking at endpoints. So we're looping through the outer contours. So if there are 2 contours, we go from I equals 1 to 2. If there are 3 contours, we go from I equals 1 to 3. Yeah, yeah, the outer loop loops over the contours and the inner loop loops over the points. So the outer loop goes over the contours, and then the inner loop, it goes from the first point in the contour, which I'm calling J naught. At the first contour, it's 1. Fortran, by the way, it uses 1 as the array base, so arrays are indexed starting at 1 instead of 0. You can change that, but 1 is the default. So this inner contour goes from J naught to the end point of the contour, and that's glyph endpoints. And then +1 because we have to convert from the TTF arrays, which are indexed from 0, to Fortran, which is indexed from 1. Yeah, another reason to dislike Fortran. You can make it indexed from 0. So I'm doing that for the glyphs. Like this is an array where I'm making it indexed from 0 instead of 1. So you can do this. And then this loop goes from 0 to the number of glyphs. But 1 is the default. I have mixed feelings about it. Actually, it's bad. Yeah, I prefer the C indexing from 0. I think this is a mistake that they made in the design of Fortran. So now we're going through points. And what do I want to call these? So the problem is when I get to the end of the contour, the next point isn't really J plus 1. It's going to wrap around to the beginning. So I think I want to set up some more integers. Naming things is hard, so I'm just thinking for a second of how I want to name things. Maybe I don't want to call this J naught. Maybe I want to call it start point. Oh, and I want to comment out this other stuff. So let's call that start point. And then this is a little bit more readable, I guess. So J is looping from the start point to the end point. And we're only keeping track of the start point of the current contour. So this is not an array. Endpoints is an array because we have all of those saved and parsed directly from the TTF file. So I have J. And then let's do JN for the next J. I could probably name things better, but I do generally prefer short variable names in a lot of cases. So I think that's correct. So let me get this other window closed. Okay. Yeah, so we have J, which is the current point, and then the next point, Jn. it's usually just j plus 1, but if we're at the end of the contour, then it loops back to the beginning of the contour. So I think that this is correct. And now, if they're both on the curve, we can just do a line segment. Is that right? Okay, yeah, there's an unmatched parenthesis there. So if they're both on curve, we just do a line segment. Though Fortran was designed to be used with punched cards, and most people would find it easier to start counting from 1, so it seems kind of logical. Yeah, the problem is that Fortran was old. So Fortran is from like the 1960s, I believe. And like there wasn't really a clear precedent that early that 0 is the most logical way to index arrays. So they just picked 1 because they were making up the rules at the time. But unfortunately, they made the wrong choice. So if these are both on curve, then we can just plot a line segment. So we have the x coordinates. I might get rid of this stuff, this 1,000 times I glyph, but I'm going to leave it in there for now so that I don't break the formatting. Instead of I, this is we have J, and then separately we'll have J, JN. So that's the x coordinate, and then we have the y coordinates. I don't know if this is even going to be valid Scilab, but we'll find out. And then no marker, it's just a line. And instead of 1, this is 2. Getting late here. I'm switched to my phone while making something to eat. Well, yeah, in any case, thanks for tuning in. I really appreciate it. no idea if this is going to compile. It doesn't. Flag n. Need to declare flag n. Something, okay, I need an extra integer in the format. So we have 2 x's and then we should have 2 y's. But we have no separator. So that looks correct. I don't know if I'll need to transpose these arrays because Scilab has separate concepts of column vectors and row vectors. And I'm not sure if that's important right now. But let's see if we can plot that. And this should be only the line segments, and then the places where there are splines should be left out, if I've done this correctly. Big if. This might be wrong. I think that's it. So those are the places where there are straight lines in the uppercase B, and then the places where we should have curves, we don't because we haven't done the splines yet. So let's see if we can fill in those curves. So if the current point and the next point are both on curve, we have a straight line segment. But if the current point is off curve, then we need to make a spline. And these are the only 2 cases that we need to handle. Else, if so if I go back to this figure, basically if we're on 5, if the current point is 5, then we need to make a spline here from 4 to 5 to 6. If the current point is 7, then we need to make a spline from 6 to 7 to the phantom midpoint between 7 and 8. But this is the only other case that we need to handle at this level. So within here, we need to figure out whether the previous points and the next points are explicitly defined, or if these are like phantom midpoints. There are other really pathological cases where this website mentions it. The entire contour could be off-curve points. Yeah, contours can even consist entirely of off-curve points. So we're going to have to be careful at the start of the contour, or if we look at the previous point to see if it's on curve or off curve, we have to wrap around to the end of the contour instead of just doing like J-1 for every case. So we have to be careful about that. I'm not sure if I'm going to do that right now, because I might have to end the stream in the next half hour or so. So I think like I don't have to worry about that for these particular glyphs, but I will have to be careful eventually. So if it's off curve, we need to find the adjacent on curve points. Let's do flag P for the previous point. A degree 5 spline curve. So what do you mean by degree 5? So like degree 2 is like quadratic and degree 3 is cubic. Is that what you mean by degree? If that's what you mean, yeah. TTF does not work like that. TTF only uses quadratic splines. I guess that's a limitation because apparently like cubic splines are a lot better. I don't really know, but the way that this is defined is that it's only quadratic splines. So like from 6 to 10, or no, 6 to 11, you might say that, oh, this is supposed to be like a degree 5 spline, but it's not. It's a sequence of quadratic splines. So in between 7 and 8, we have like a phantom on-curve point, which is compressed out. So the TTF file does not explicitly store the on-curve point between 7 and 8, but as like a rule of the file specification, they say that whenever you have two consecutive off-curve points, that's implicitly defining an on-curve point at the midpoint between them. So that's just the way that TTF works. So instead of n, so this is wrong. The previous index is not always j minus 1. In some cases, this will have to loop around to the beginning of the contour. But I think I'm not going to bother with handling that right now. So we have previous, and we already have next, so we don't need to get the next flag again. Now, we're going to make 3 points, A, B, and C. These are going to be two-dimensional. So first of all, I want to have a parameter for the number of dimensions. ND for the number of dimensions is 2. And now I can have like a bunch of fixed size arrays, which are all two-dimensional, or ND. So I guess they have to be integers. Yeah. So A, which is n-dimensional, B, and C. Now B is the middle point. So I did not mean to open Chrome. So if we're on point 5, our spline goes from 4 to 5 to 6. 4 is going to be A, 5 is going to be B, and 6 is going to be C. B is simple because it's always the current point. A, it's going to depend on whether that previous point is explicitly defined or whether it's one of these phantom implicitly defined midpoints. I'm not sure if the terminology I'm using is correct. I don't know if this is really called a phantom point. I think maybe they use phantom points to describe something else. So yeah, don't quote me. But point B is easy. B is always the current point. No, I already have a comment for that. So B is always the current point. It's glyph X, colon for X and Y, and then J. J is the index of the current point. Now for A and C, we have to check if it's explicitly defined or not. This is a quadratic Bézier spline with point J as the middle control point. So that's B. Now A and C are trickier than B because B is always just the point at index J. A and C, it's going to depend on whether the previous point is on curve or not. So I want to check flag P for the previous point. This means it's on curve. So if it's on curve, then A is just going to be the previous index. Then, this gets even trickier. So we're going to have to subtract 2 points, but this could also wrap around to the beginning of the contour. So if it's a phantom point, it's going to be like the weighted average, or like just the average of the previous 2 points. So it's going to be 0.5. I think this should cast to integer correctly, but we'll have to see if this compiles. So x jp minus 1. We're going to have to be careful about wrapping around, but I'm not going to worry about it for now. Plus just jp for the previous point. So jp is the previous point, and then jp minus 1 is the point before the previous point. This might wrap, so I'll put a to-do note for myself to handle that later. So that's A, and then C is going to be similar to A. So A is the start point. Then B is the end point. That's not B, that's C. So B is simple, we don't need any logic for B. C is the endpoint. If the next point is on the curve, then it's just the next point. Otherwise, it's another one of these phantom points that's implicitly defined as the midpoint between the next point and the point after the next point, jn plus 1. I think we might actually have a problem here, even for the uppercase B. Maybe not, we'll see. First of all, this isn't going to print anything yet, but I want to see if this compiles and runs without crashing. Well, I don't think I declared J, N, or JP. So JN, I need JP. That built. And then it didn't print anything because we didn't do that yet. Now, the way that I would like to plot this in Scilab is Scilab only prints straight lines. So I want to break up the spline into a bunch of very short line segments that approximate the curvature of the spline. So I'm going to have some number of line segments that I'm breaking it up into. I'm just going to call that like NS for N spline. This is like the number of line segments that I'm breaking a spline up into. So we have points A, B, and C, then we can iterate through everything in between A and C. But I want to print Scilab code. So like the way we did it before, where we start an array, I want to copy that. Start the array and then close the array. And then within these square brackets, I want to print the broken up points of the spline. So we're going to have like the spline parameter t. If I go back to this, we're going to use this equation. So I need to copy because I'm moving between different NVIM windows now. And then paste. That's not valid Fortran, that's just pseudocode. We're going to have to, actually it's pretty close to Fortran. So we're going to loop along T. I think in Fortran that you can just straight up use a real value as the loop iterator. I'm not sure, but in any case, I'm not going to do that. I'm going to use an integer and then convert an integer it to some floating point value t. This is going to go up to n spline. So n spline is like the number of line segments, but then the number of points is going to be n spline plus 1. So that's why we're starting the loop at 0 and going all the way up to inclusively n spline. And then now I need like a floating point value, or Fortran calls it double precision for a double, t. T is going to be the spline parameter that goes from 0 to 1 along the length of the spline. So to convert that integer to a real, it's pretty simple. It's just going to be 0 times it over n spline. Does Fortran have a graphics library, or how am I going to implement the graphics later? No, it doesn't have a graphics library. So what I'm doing right now for today is I'm using a separate program called Scilab to visualize and plot this stuff. What I'm going to do later is store this stuff as pixels myself and then write a ppm file. Ppm is like a very simple image format that you can write yourself from any programming language without using a library to read and write the file. I don't know if you've heard of the streamer Soding. He is working on a graphics library in C, and that's the same thing that he did at first. So that's my plan. I'm not there yet. I have like a to-do note at myself to like visualize this in Fortran, but I'm not going to get to that today. So now I think we can just print these coordinates. Yeah, it's a simple bitmap. I think even the BMP format is non-trivial. I don't really know what's in a BMP format, but ppm is even simpler than BMP, so it's trivial to write. I think A, B, and C are already two-dimensional. And this might just work. This might be valid Fortran code. So let's see what that does. Doesn't compile. Or did it? No. I have to fix some of these warnings so that I don't scroll so far. I forgot to declare IT. Okay, I think that ran. So that's printing stuff. Let's see what that looks like. Oh, well, I'm just printing X. Now I need to plot that. So I want to print the Scilab command to actually plot this thing. That's going to be like I did here. Here it is, the moment of truth. Will this work? Probably have some errors at like the end point where I'm not wrapping around. Let's see. Ooh, it's close. It's close. That's almost a letter B. There's some funky stuff going on. Not really sure what's happening there. But it's pretty close. It's like I'm going beyond the range from 0 to 1 somehow. Or this logic might not be right, or this logic. Yeah, but it's fairly close. JP is J minus 1. Did I ever define JN? Yeah, JN is J plus 1. I don't think I ever, no, I got flag N. Yeah, well, there's definitely some bug in here, but it's fairly close. Let me go back to the lowercase b. So that's uppercase. This is lowercase. this was some compound glyph. This probably has the same bugs. Dinner's ready? Yeah, well, I'm just about done, so you're not going to miss anything. I think I'm going to get this committed, even though there's a bug, and then I'm going to end the stream. So thanks a lot for joining. I really appreciate it. Let's see what lowercase b looks like. Okay, yeah. So there's definitely wrapping around. Fortran has bounds checking, so it tells you if you try to index something out of bounds, at least if you compile with the option to check that. If you optimize your code, and compile without bounds checking, then it won't tell you about this. And it even tells you the line of source code. So 607. Yeah, so obviously I have to wrap around if n jn plus 1 is beyond. Thank you. Thanks, I appreciate it. You do the same. What if I cast some things to floats? I mean, that's not going to help with my my indexing problem. I think some of these might be off by 1. This might be off by 1 because start point, oh no, it's 1. I think that's okay. Yeah, I don't think I have time to fix this right now. I think I need to wrap up the stream. I go back to capital B. I know this at least runs without crashing, so I think I feel good enough about committing that. Is that right? Where? Oh, I didn't redirect it. Yeah, so it kind of looks like shit, but like we're close. I know I have to fix those wrapping around errors, and then I'm not entirely sure why some of these splines are shooting off past where they should end. But in any case, I'll fix that at a later date. Let's give this a quick review. Did I ever update start point? Okay, I do update start point at the end of the outer loop, so that's good. I think I'll commit it right there. This is work in progress because it doesn't really work correctly right now. So I want to check that that pushes. Okay, something didn't work in the last commit. It's not working in this one either. So it doesn't like that. Didn't we do this before? What are these types? So on curve has to be 2 bytes. Does this actually change anything? I don't think this is related to my bug. Yeah, that doesn't really change anything, but it should compile on the cloud now and pass CI. All right, that did something on Ubuntu. Let's just check what it looks like. So let's copy and paste from there to the end. What's going on? What are you talking about? Where's the x equals? Somehow this did not copyright, I think. Yeah, I don't know. It's not formatted correctly, so this isn't syntactically correct Scilab code. So I think I'm gonna have to end it there and wrap up the stream and call it a day. Thank you to everybody who tuned in. I really appreciate it, and I will catch you next time. Bye.